Welcome back to AS Chemistry. In this Theme 2.1, we'll study chemical energetics. This includes enthalpy changes, exothermic and endothermic reactions, bond energies, Hess's law, and calorimetry. These concepts explain the energy changes that take place when reactions occur, whether heat is released or absorbed, and how we can measure it. Let's begin. Enthalpy and enthalpy change. Enthalpy is the total heat content of a system at constant pressure. We can't measure absolute enthalpy, but we can measure changes in enthalpy. An exothermic reaction releases heat to the surroundings. The enthalpy change, delta H, is negative. Examples include combustion and neutralization. An endothermic reaction absorbs heat from the surroundings. The enthalpy change is positive. Examples include thermal decomposition and photosynthesis. Worked example 1, exothermic versus endothermic. Question: the combustion of methane releases 890 kilojoules per mole. Is this exothermic or endothermic? Answer: since heat is released, delta H is negative. This is an exothermic reaction. Exam tip: always state the sign of delta H. Exothermic is negative, endothermic is positive. Mini quiz: is the decomposition of calcium carbonate exothermic or endothermic? What is the sign of delta H for neutralization? Standard enthalpy changes. We define standard enthalpy changes under conditions of 298 Kelvin, 100 kilopascals, and 1 molar concentration for solutions. The standard enthalpy of formation is the enthalpy change when 1 mole of compound is formed from its elements in their standard states. The standard enthalpy of combustion is the enthalpy change when 1 mole of substance is completely burned in oxygen. The standard enthalpy of neutralization is the enthalpy change when 1 mole of water is formed from the reaction between an acid and an alkali. Worked example 2, formation versus combustion. Question: write the equation for the standard enthalpy of formation of water. Answer: half O2 plus H2 gives H2O, liquid state. 1 mole of water is formed. Question: write the equation for the enthalpy of combustion of methane. CH4 plus 2O2 gives CO2 and 2H2O. Exam tip: always balance equations carefully and specify the correct physical states. Mini quiz: what are the standard conditions for enthalpy changes? Write the equation for the enthalpy of combustion of ethanol. Bond enthalpies. Bond enthalpy is the energy required to break 1 mole of bonds in the gaseous state. Breaking bonds requires energy, so it is endothermic. Forming bonds releases energy, so it is exothermic. The overall enthalpy change of a reaction equals bonds broken minus bonds formed. Worked example 3, bond enthalpy calculation. Question: calculate the enthalpy change for H2 plus Cl2 forming 2HCl. Bond enthalpies: H-H equals 436, Cl-Cl equals 243, H-Cl equals 432. Step 1, bonds broken equals 436 plus 243 equals 679. Step 2, bonds formed equals 2 times 432 equals 864. Step 3, delta H equals 679 minus 864 equals minus 185 kilojoules per mole. Answer: the reaction is exothermic. Exam tip: don't forget to multiply bond enthalpies by the number of bonds broken or formed. Mini quiz. Why is bond breaking endothermic? Why is bond formation exothermic? Hess's law. Hess's law states that the enthalpy change of a reaction is the same no matter which route is taken, provided the initial and final conditions are the same. This means we can calculate enthalpy changes indirectly using energy cycles. Worked example 4, Hess's law. Question: the enthalpy of combustion of carbon is minus 394. The enthalpy of combustion of hydrogen is minus 286. The enthalpy of combustion of methane is minus 890. Calculate the enthalpy of formation of methane. Step 1. Write equations. Formation: C plus 2H2, arrow CH4. Combustion route: C plus O2, arrow CO2. Delta H equals minus 394. 2H2 plus O2, arrow 2H2O, delta H equals minus 572. CH4 plus 2O2, arrow CO2 plus 2H2O, delta H equals minus 890. Step 2. Apply Hess's law. Delta H formation equals minus 394 plus minus 572 minus 890 equals minus 966 plus 890 equals minus 76 kilojoules per mole. Answer: the enthalpy of formation of methane is minus 76. Exam tip: always draw an energy cycle diagram if you get stuck. It helps avoid sign errors. Mini quiz. State Hess's law in simple words. Why does Hess's law work? Calorimetry. We can measure enthalpy changes using calorimetry. The heat absorbed or released is given by Q equals mc delta T, where m is the mass of solution, C is the specific heat capacity, and delta T is the temperature change. We then calculate molar enthalpy change as Q divided by moles. Worked example 5. Calorimetry. Question: 50 cubic centimeters of 1 molar hydrochloric acid reacts with 50 cubic centimeters of 1 molar sodium hydroxide. The temperature rises by 6.5 degrees. Calculate the enthalpy of neutralization. Step 1. Total mass of solution equals 100 grams, assuming density equals 1. Step 2. Q equals mc delta T equals 100 times 4.18 times 6.5 equals 2,717 joules. Step 3. Moles of water formed equals 0.05. Step 4. Delta H equals minus 2,717 divided by 0.05 equals minus 54.3 kilojoules per mole. Answer: the enthalpy of neutralization is minus 54.3. Exam tip: don't forget the minus sign if the reaction is exothermic. Mini quiz. What formula is used in calorimetry? Why do we divide by moles to get molar enthalpy change? Closing recap. In this chapter, we explored enthalpy changes, exothermic and endothermic reactions, standard enthalpies, bond enthalpies, Hess's law, and calorimetry. We practiced calculations for bond enthalpies, enthalpy cycles, and calorimetry, and we added self-test questions at each step. Chemical energetics is a core skill for AS chemistry because it combines concepts with calculations. The more you practice, the more confident you'll be in exams.